Welcome to this 2022 question C3 the mock exam. So I think starting it off is fairly simple, right? So 60 degrees, down 45, this line is at 30 degrees, 70 long. Then to get the square inside, step 20 left and right, the centre line, draw parallel to the edges. Now, if you want to get C, okay, go up vertically from C until it hits the element apex, or the edge apex to 2. Now, if you're reading the question, it says we've got the designed base and square base pyramid with a removable top, shows the projection of a similar open jewellery box with its lid resting on its side. With a rotation. Part A, draw the given plan elevation of the box and lid. So you draw the box first and then the lid. Right, so what we're going to do is a rotation. Okay, we're going to look along this line here, parallel to the base. That's on. Okay, that's on the XY line elevation. So it's a true length and plan, and this is parallel to the XY line in elevation. So it's a true length. So they're both the same dimension. So the lid is placed flat and then rotated into position. So we'll take an auxiliary, put our compass here, and rotate them down. And then we're going to project back to our plan and perpendicular to our hinge line. Okay, till they intersect, and then we'll find the dihedral angle. Okay, so I'm going to set one up here. So 40 long. I'm going to do this light. Apex. Now we're going to draw in an X1, Y1 line. So we're going to project these points up. Now I'm going to call that B, A, C, D. Take the height from here, same height. Put it there. Now, that's C1/D1, B1/A1. We're going to take our compass, rotate our apex down onto the X1, Y1 line. And then I'm just going to extend that, and we're going to project back down. And then I'm going to take, so I took that distance, rotate it down. Then I'm going to swing from here and put my compass there, rotate A to B, where they intersect. And then I can bring this back here and bring this down. So hidden detail, or a heavy detail here. And hidden detail here. And then apex, B1A1, B, A. Now I'm going to project to elevation, the height there. B and A, I'm going to project the height up. The height can be taken from our auxiliary elevation. So take the height from here, step it there, and it's not in line with the cut surface and elevation. That might be a common mistake students make. Project up, D and C. Sort of heavy that in. Hidden detail here. Close that door. Close the door. Close the door. Yes, thank you. Good. Now, here we've that done. Now we just have to find the dihedral angle between Q and S. So I could do that using a rebatment or a dihedral angle, or the auxiliary. I'll be using the auxiliary, so that's the way I prefer to do them. So going to check, is line B to 1 a true length in elevation or plan? No, because it's not true length, or it's not parallel to the XY line in either view. So I'm projecting perpendicular to the line of intersection. I'm going to take in, or draw in the next one, Y1 line. Now I'm going to take the heights from elevation. So all of them are the same. So I just take the height of C there. So C. That's O. C1, A1. C1. It's the height of B there. B1. And there's the height of 1, or there on the XY line. So now the line of intersection is the true length. Now Q, and then surface S is hidden behind Q. Now this is the line of intersection, so that needs to project as a point. So I'm going to look along that line of intersection. So I'm going to draw in my X2, Y2 line. Now, take the distances from the X1, Y1 line back to plan, so 2. Mark 2 in. C. A. Oh, sorry, I'm projecting. Sorry, what was I doing projecting C from there? That's on the wrong point. So go back to 0 there. So we need that. C and A are on this projection line. And then A. There's B. Now there's 1/B2. Okay, C2, A2, 0, 2. and we can join them together. Tiny bit off there. Now then we're going to get a protractor and measure the dihedral angle, and it's going to have an angle of 100 degrees. So there we go, 100 degrees hedral. Now, last part, triangular surface. Okay, determine the horizontal and vertical traces of the plane that contains the triangular surface T. Right, very easy mistake to think it was the base. It's the triangular surface DA apex. So DA apex. Now, because line apex to D is on the XY line elevation, that means it's on the horizontal plane, because the XY line is an edge of the horizontal plane in elevation. So this is, okay, line D to the apex is the HT in plan. So T, there's H. Now, okay, if you want to get the vertical trace, alright, I draw a line parallel to the HT in plan through point A, and where that hits the XY line, that's a point on the VT. Because the vertical plane is represented by the XY line in plan and the VT is on the XY line, okay, because it's on the vertical plane. So I'm going to project this point up, and then parallel lines are parallel in every orthographic view. So we're going to go parallel to the horizontal plane, or the horizontal trace in elevation, which is on the XY line, from letter A, and where they intersect, okay, we're going to join back to T. So there's a vertical trace. Okay, cheers, thank you, bye bye.